Hello, I am Ken Shirahata. Today, I'd like to talk about verification of right-time behavior in SUMO at a signalized intersection. We are developing new method for traffic signal control, and we use SUMO to evaluate the ability of our proposed method. When we generated a signalized intersection in SUMO, we wrongly set parameters of junction model. As a result, a strange phenomenon happened that right-time vehicles forced oncoming vehicles to stop. In the end, we noticed the problem of the parameters and solved it by setting appropriate values. Here, if we have ignored the problem and evaluated our proposed method, the results should have had low reliability. Thus, it is very important to verify the simulator and understand how vehicles behave in order to ensure the reliability of the evaluation result of our proposed method. That is why we studied to verify SUMO. This time, we show the results of verification focused on right-time behavior at a signalized intersection. This is a way of verification. This time, we focus on right-time capacity at a simple signalized intersection. The characteristics of right-time behavior are clarified by comparing the simulation results and the theoretical value, which is shown as this equation at several cases. Among these cases, oncoming through demand and effective green time are different. This is a result of verification. In all cases, the right-time capacity in SUMO is smaller than theoretical value. This means the number of passing right-time vehicles during effective green time tends to be smaller than we expect. Why such results were brought about? If it is a problem of right-time behavior in SUMO, we need to revise it. Here, regarding right-time capacity, distribution of gaps of oncoming vehicles is important, as well as the right-time behavior itself. This is because when right-time vehicles which have lower priority turn right, they utilize gaps between oncoming vehicles which have higher priority. So, we focused on the distribution of gaps and analyzed it. In the theoretical equation, Poisson distribution is assumed as the distribution of gaps, since vehicles are generated following the distribution. On the other hand, the graph indicates that observed gaps tend to be smaller than the theoretical ones. That is why the smaller right-time capacity was observed in SUMO. Well, this time we estimate two reasons of the difference of gap distribution. Why is that distance between two oncoming vehicles changes while they run from their origins to the intersection because of the difference of vehicle speed? The other is that vehicles are not always inserted following Poisson distribution in the first place, because the timing of inserting vehicles are dispersed in time steps. Anyway, the cause of the problem is not the behavior of right-time vehicles itself, but the gap distribution of oncoming vehicles. In other words, we can conclude that there are no problems about the behavior of right-time vehicles in SUMO. This is a summary of our study. As a result of verification, we concluded that SUMO reproduced real behavior of vehicles well, and therefore it could be a reliable tool to evaluate our proposed method. We would like to verify SUMO at different points of view and organize the characteristics as a traffic simulator. If you have any questions or comments on our study, please send a chat to us. Thank you very much for listening.